In problem number 12, we have a graph of a differentiable function f on a closed interval from 1 to 7, shown in the picture there. And h of x is the integral defined function from 1 to x of f of t dt on the interval from 1 to 7. X is greater than or equal to 1, less than or equal to 7. And the first thing that we want to do is find out what h of 1 is. Now, by definition, h of 1 is the integral from 1 to 1 now of f of t dt, and this is just a property of definite integrals. Integral from 1 to 1, or from any number to itself, is always 0. And that's the answer to A. Now h prime of 4, and the derivative of h then by the fundamental theorem of calculus is the derivative of this integral defined function from 1 to x of f of t dt. And we know by the fundamental theorem that that is just f of x. And so therefore h prime of 4 is really just f of 4, which is 2. And so that's our answer for B. Now part C says, on what interval or intervals is the graph of h concave up? Justify your answer. And so I say that h is concave up when the second derivative of h is greater than 0. Now since h prime of x is f of x, h prime prime of x is f prime of x. So the second derivative of h is the first derivative of f, and f prime of x is positive whenever the graph that we see there has a positive slope. So that's for x's 1 to 3 and then from 6 to 7. And that's our answer for part C then. Now for part D, we want to find the value of x at which h has its minimum on the closed interval from 1 to 7. And since this is a continuous function on a closed interval and we're looking for its minimum, so we're looking for the absolute minimum, we're dealing with the extreme value theorem. And by the extreme value theorem, now you don't necessarily have to say what that is, which it states that a continuous function on a closed interval always has an absolute max and an absolute min, and they will occur at critical values and endpoints. So we say that by the extreme value theorem, the absolute min must occur at critical values or at endpoints. Now the only critical value, that is where where h prime of x equals 0. And h prime of x is just f of x, and that occurs at x equals 5. But because that is a relative maximum, h prime changes from positive to negative, so that's a relative maximum there, and that cannot be the absolute minimum. Now since so it has to be at the endpoints, and h of 1 is equal to 0, and h of 7 is greater than 0 because the area accumulated from 1 to 5 is greater than the area that is subtracted from 5 to 7. So that means if we're starting at 0, at 7 we have some positive area left over. So therefore the absolute minimum must be at x equals 1. So that is the x value at which h has its minimum on the closed interval from 1 to 7. Okay, we'll go on to the next problem.